All right, good afternoon, everyone. Welcome back to MDE 54. I know I'd said that there was a chance class could have been canceled today. It's not, but I wasn't able to fully resolve the issue going on here. So it's going to be a pretty short class, only like 25 minutes. And basically what I'm going to do is take the examples that we were going to go over where I would give you, 5 minutes to do each and then come back and actually go over them. I'm just going to lay the examples out and go ahead and go over them. So if you would prefer having the time between me giving the example and going over the answers, what you could do is just watch this on YouTube later after class is done, a couple hours when everything's been uploaded, since it takes a while to convert and everything. But I would say, I'd prefer you to stay, and you could always do that later. But whichever you prefer, go ahead with. We'll have, a more normal class when we come back on Monday. But for now, let's go ahead and do some examples dealing with the total change, percent change formula.
All right, so first example. Bob earns $30,000 in 2019. He earns $45,000 in 2020. What was his total change and percent change in income? Pause. All right, so this is where you try the problem on your own. You wait 5 to 10 minutes. Then you'll unpause and you'll come back and you'll see me do the solution. Again, try this on your own. You don't learn math by watching someone else. You learn math by doing it yourself. All right, so we have our old and we have our new. So our total change, which I'm going to abbreviate as TC and then PC for percent change, or the percent symbol and a C. That's the new minus the old. So that would be $45,000 minus the $30,000. Let me squeeze that dollar symbol in there, which would be $15,000. Now, I didn't say Bob got a raise. I just said he earned this much and this much. Maybe he worked more hours. Maybe he got a raise and worked more hours. Don't know. We said we do like to mark whether this is an increase or decrease. Since it's positive, it's an increase. So his total change in income was it increased by $15,000 in 2020. He made the $30,000 from last year, and then he made $15,000 more via a raise or working more hours or something else. Then our percent change, this is the ratio of that figure we just got, the total change. So that's the $15,000 divided by the original amount. So that's the 45, right? Nope. The original, the 30,000. When you do that, your dollar symbols will cancel. Your units tend to cancel for percent changes because you're comparing one type of unit to the exact same type of unit. So they should always cancel. 15 over 30 is the same as a half, which is the same as 0.5. So that would be 50%. And because the total change was an increase, this was also an increase. So we can say that Bob earned $15,000 more in 2020, and that was a 50% increase over his income from the previous year. That's the quantitative reasoning student's answer. And again, the total change, $15,000 sounds amazing, especially when you're making $30,000 the last year. But if you made $1 million last year, $15,000 isn't really a huge increase. So that's the awesome thing about percent change, is it's relative to what happened in the past. So in this case, given that the past was 30 grand, that was 50% increase. So he made an extra half of his previous income. That's what it means to be a percent change. All right, next example. I really like the income ones, and you'll see me do some more income problems in the QR class on Thursday, but I'll also approach them from different angles. I won't just always give you the old and the new. Maybe I give you the percent change and you got to figure out the new. Or maybe I give you the percent change and the new and you got to figure out the old. So we'll be doing all of that next time, but not today. So Bob earned, say, $80,000 in 2019. He earned, let's say, $65,000 in 2020. What was his total change in percent change in income? Same question. So this is where we pause 5 to 10 minutes, however long it takes you to get this done. get your answer. Ask yourself if it makes sense. We can always do that as well. And maybe after the first one, it might not make sense or not make sense if you did it right or wrong. But after you do a bunch of these, hopefully the sensibility starts coming to you. So pause. 5 minutes, 10 minutes pass, and unpause. All right. So our total change, it's going to be the old minus the new, right? Inflection and voice? No, it's still up here. New minus old. The newest thing minus the oldest thing. So the new, well, that's the 80,000. No, 2019, the larger number was actually the old, and the smaller number was the new. So maybe Bob did something bad and he got a demotion, so he lost some of his pay. He got a pay cut. Or maybe Bob worked less hours, or maybe Bob just got a new job entirely, so he's making less money at this new job. Maybe he's only working half as long. I don't know. There's some reason this happened, but we're not focused on the reason. We're focused on the math and the reasoning with the math. So new minus old is 65K minus 80K. In your own math, you could literally write 65K minus 80K, and you get negative 15K, which is the same as negative $15,000. So that would be a $15,000 decrease. He made $15,000 less in 2020 for some reason that we didn't discuss. Now the percent change, again, is the ratio of the total change, the thing we just found, to the original amount. So total change is a dollar amount, percent change is a percentage, no other units. Total change doesn't have to be dollars. If we're talking about apples, then it's apples. If we're talking about people, then it's people. But this is in dollars, so total change was dollars. So the percent change is the total change of the 15K, the 15,000, divided by the original, the thing that happened first. The bottom has nothing to do with size. It's not the smallest, it's not the largest, it's the thing that happened first. It's the thing that happened first. The bottom is the thing that happened first. I repeat myself because people forget things. Now the thing that happened first was the 80,000. And if you want to do 15,000 divided by 80,000, we'll pull out a calculator. Where are you, calculator? There we go. Boom, boom. Let's get our notes back up. So 15,000 divided by 80,000, I can literally just type 15 divided by 80. I could have also reduced that. 5 goes into both of those some number of times. No matter whether you reduce it or write the 15,000 divided by 80,000, you'll get 0.1875. So that's negative, I forgot my negative symbol here, but negative 0.1875, I believe. 1875, yes, 1875. That is not a percentage, that is not your answer, you must convert it. Decimal goes right twice. Remember, a percent should always look bigger than its decimal equivalent. And we get 18.75% negative, which is a decrease. So you can say negative 18.75%, or you can say it's an 18.75% decrease in pay. He's not making 18.75% of his previous salary. That's not what we're saying. We're not talking about a percentage of something. We're talking about a percent change. They are very different things, and it's easy to mix up those concepts. Okay, let's try another one. Bob earned 65K. There's my dollar symbol, there we go. In 2019, and he earned 80K in 2020. What, blah, 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 blah. What's his total change? What's his percent change? We pause. Take 5 to 10 minutes. You try this on your own. You don't just let me do all the work for you. That's not how this is supposed to go. Pause and try this on your own. Maybe watch me do the first one if you don't feel confident or comfortable. With the second and the third, you should definitely be trying on your own. I'm doing the same thing over and over and over. And we unpause. Well, Mr. Beckner, these numbers are the same ones you gave me last time, right? Well, yes, but now the old is the smaller and the new is the larger. So the total change is not 65 minus 80, it's 80K minus 65K, which is positive $15,000. So that's a $15,000 or 15K increase in salary. This time we reversed it. He went from making less to more. So the total change is positive $15,000, whereas last time it was negative $15,000. So the value of the 15,000 didn't change, it just changes in sign. And that's because we reversed the order of how it happened. So that's the key element of total changes. If you swap the old and the new, the total change is just opposites. But the percent change will always be a different value. If you go from a smaller to a larger, the percent change will be a bigger value than the opposite scenario of going from larger to smaller, because you're scaling this to the original, and the smaller the original is, the larger the percent change will be. Because remember, the smaller the number in a bottom, the bigger the answer is. We did a big old discussion of that, not discussion board, but a discussion in class. So percent change is the increase or decrease, increase in this K, the 15K, no comma. So that was the total change divided by the original, the thing that happened first, which was the 80K. So the thousands will cancel, the dollars will cancel, and then 15 divided by 80, or 15,000. What did I do wrong? Not 80. Pardon me there. We said the 65 is what happened first. See, I was about to make a mistake, but I caught it because I looked at that number carefully. I'm trying out something new today. My vision is never great to begin with, but I've got some of those blue UV light preventers things on, and they're not the prettiest thing in the world to use. Anyways, so sorry about that, but anyways, the old amount was 65,000. So that's what we should have been dividing by. The dollars and thousands still cancel, but we're doing 15 divided by 65. And we get 0.2307, blah, blah, blah. So if you move the decimal twice to the right, that'll be 23.1 if you round to the nearest tenth. So 0.2307, which is going to be 23.1%. 23.07 just rounds up to 23.1. And that would be an increase in pay. See, when you start with the larger value, the percent change ends up smaller. When you start with the smaller value, the percent change ends up bigger. And again, that's because the smaller the number you divide by, the bigger the answer. Tops didn't change in these scenarios, 15, 15. The sign did, but not the value. It's the bottoms that changed. So that was that what if analysis we did back with the stock market stuff. All right. Let's change up the topic some. Keep Bob though. Bob runs a store and he sells 4,050 items his first year. Second year, sells 4,900. Wrong place for the comma, 4,900 items. What was his percent change and total change? Not in that order, total change and then percent change. You can't do percent change without knowing the total change because it's one of the parts of the formula. Well, how did you know that? Look at the formula. All right, so we pause 5 to 10 minutes. We come back, you've got the idea. We'll do one more after this. And our total change, let's get back to black. I just did that in blue because I swapped numbers. So the total change is the new minus old. The 4050 is the old. The 4900 is the new. So we're doing 4,900 items. I didn't say what, we're just generalizing, minus the old amount, which was 4050 items. So whatever the subtraction is, the answer is items. 4,900 minus 4050, well, that's going to be 850. So 850 items, and that's a positive answer. As I said, writing this up by hand, we tend to like to see the plus in this course. When you put in your answers in My Math Lab, you probably don't want to be putting that plus in there. So that was an increase in the number of items he sold. I'm not saying he made more money. I'm just saying he sold more items. What do you mean more items? Do you mean 4,050 different types of items, or 4,050 items total where maybe half of them were refrigerators and then some of them were stoves and then the others were tables? I didn't say, and it doesn't matter because there was no question about specific items. Now, I could break these down into categories and then ask you to talk about percent increases and decreases of tables and tubs and whatever else I just said. All right, so percent change, the ratio of your total change, which we just got, which was the extra 850 items. And then we divide that by the original, which was the, we're not going to make any mistakes this time, the 4050 items. The item units will cancel, so we're just doing 850 divided by 4050, which is the same thing as 85 divided by 405, and you could keep reducing that. Let's just write the original numbers though, 850 divided by 4050. And you get that answer. If you don't trust me on that, you can cancel out a 10. Here's 85 divided by 405. Same answer. And if you divided both of those by 5, you'd get, what's that? 17 over 81. Same answer. So 0.20987, let's just go 4 decimals originally, so 0.2099. And then you're going to move that decimal right twice. And that's the reason that I do so many decimal places here. I don't just want to do 1 or 2 here, because when you move that right twice, you're going to need to see some of these other digits for the rounding to 1 or 2 places, whatever they ask for. So that would become 20.99%, or if you round this to the nearest tenth, it actually rounds to 21%. It's positive, so an increase. So he sold 21% more items. Maybe it's 21% more item types. Maybe it's just items in general. I don't know, and we don't care for the context of this problem. All right. So last one. Bob's teacher gave him, let's see. Trying to think of a well-rounded, not rounded number, but a number that would make sense. Let's see, maybe 30, 60, 600, let's say 900 problems this semester. And his teacher, so he had the same teacher, maybe even the same class, I don't know. Hold on, give me 1 second. So Bob's teacher gave him 900 problems this semester, and his teacher gave him a 749 problems last semester. Find the, or let's, yeah, I'll say it a little differently. Find the total change and change. So same 2 questions from the last 5 examples roughly. So this is where we will pause, and then you'll take 5 to 10 minutes to try and work on these on your own. Remember, you can always actually pause, which is what you should be doing. You can go and rewatch previous examples that we did earlier in the video, whatever you have to do. And now we'll pretend like the 5 or 10 minutes has passed. Where did my indicator go? There we go. And now I will give you the solution. And remember that if you get caught while working on the problem on your own, you can always play the next minute or so to see how it starts. So our total change is going to be the new minus the old. And you might get in this pattern of thinking, oh, well, the new is the second and the old is the first. But I worded this problem specifically to throw you off because that's how the last 4 or 5 have been. But if you pay attention to the words, it is seen that Bob's teacher gave him 900 problems this semester and 749 problems last semester. So it actually turns out that the 900 is the new this time and the 749 is the old. So don't just think that it's always the first is the old and the second is the new. The words will tell you which is which. So your total change is actually going to be 900 problems minus 749 problems. If you do that subtraction, you'll get 151 problems. And that would have been an increase since this is a positive value. So again, if you did this wrong, you'd think that the teacher gave him 151 less problems this year. But again, that's because you would have done the problem backwards. You would have done old minus new because you got comfortable in patterns and didn't pay attention to the details. So that'll make our percent change. We're going to take the total change of the positive 151 problems. Again, that's an increase. I totally should have made that answer a 99, but I didn't think about it until just now. Next semester, and then we'll divide that by the original, the old, the thing that happened first in time. And again, not the 900, not the first thing in the sentence, the original, the thing that happened first in time. So that's the 749 problems. So we're going to have to cancel those problems. So this will be unitless. We'll do 151 divided by the 749. If there's a reduction there, I don't see it. And you get 0.2016 blah, 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 0.2016. You'll move that decimal right twice, so you get 20.16% or 20.2%. I am just rounding all these to 1 decimal place as a percentage, and that would be an increase. Again, the context of the problem may say to round to 2 decimal places. It may say to round to the nearest whole percent, but you have to be careful. If you had taken, if I said to round to the nearest tenth of a percent, if you go, oh, we'll just round to the nearest tenth, you would have said this is 0.2. Then when you move the decimal right twice, you get 20%, and 20% is not the correct answer because you're missing the 10th position. So that's one thing to be careful of when you're told to round a percentage. You will need more of the numbers, more of the digits as a decimal, and then you'll go to the rounding when you get to your percentage. So again, that would have been wrong because you rounded too soon. Don't round the decimal value, round the percent value. Use 3 or 4 or 5 extra digits than you think you actually need with the decimal value. All right, so that is where I'm gonna cut it with all.
All right. So as I was saying, that's where we're going to end today. Since we had just not the time available today, I guess is what I need to say. All right. So everything should be back to normal on Monday. Regular Math 154 class, which wasn't different today. Regular MDE 54. So have a good weekend. Work hard. Don't forget to keep up with those MDE homeworks as well as the Math 154 homeworks. Besides that, as always, if you have any questions, shoot me an email, and take care, everybody.